Hello, everyone. Thank you for coming. Let's start. First of all, I would like to stress that a hypersphere is an example of a three-manifold which locally behaves like Euclidean 3D space, just as a sphere looks like a plane to small enough observers. In classical physics and our everyday life, we use alleged space 3D Euclidean and solar time t. My model based on cosmological time tau that is defined by impedance, wave resistance of the medium that equals to Hubble's parameter h. Cosmological time is inversely proportional to h. It marches on at a constant pace from the beginning of the world up to the present epoch, along with time-varying cosmological parameters, and defines the absolute age of the world. Time is not a physical dimension and is absolutely different entity than space. Time is a factor of the world. Let me remind you the main results of the second presentation, multi-component dark matter. Critical energy density of the world can be found by the Hubble's law only. There is no need in general relativity. Medium consists of stable elementary particles, protons, electrons, photons, neutrinos, and dark matter particles. The relative energy density of ordinary particles, about 4.8% in the medium, which was experimentally measured by fast radio bursts, 2.4% in macro objects, and the rest, 92.8%, is the relative energy density of dark matter particles. What else could be? Multi-component dark matter system explains a diversity of very high energy gamma ray sources in the world and the diversity of dark matter cores of macro objects of the world, superclusters, galaxies, and extrasolar systems, which are fermion compact objects and dark matter reactors in our model. Binary gamma by Giovanelli and Haynes in 1989 and by Minchin et al. In 2000. Prediction of John Michel of the existence of dark stars is valid for dark galaxies also. There is no need in dark matter to explain galactic rotation curves. It might be the explanation by Ludwig, the gravitomagnetic field produced by the mascaras, and the Hilster, who calculated the rotational curves as a disk instead of a sphere. Unidentified infrared emission bands around peaks at 3.3, 6.2, 7.7, 8.6, 11.2, and 12.7 micrometers, which are the fingerprints of all galaxies, explained by the self-annihilation of dark matter particles DMF4 with rest energy 0.2 electron volts instead of the polycyclic aromatic hydrocarbon molecules, not a single member of which had been identified in space definitively for 45 years observations until now. 21 centimeter emission with the broad line width explained by the self-annihilation of ensemble of ultra-relativistic dark matter particles xions instead of the forbidden transition in neutral hydrogen atoms for which there is no explanation for a mechanism of their production. Dark galaxies are made of dark matter particles only. Angular momentum problem. Angular momentum problem is one of the most critical problems in standard cosmology that must be solved. Professor Leon Mestel, in his paper on star formation in Quarterly Journal of the Royal Astronomical Society in 1965, realized the full extent of the angular momentum problem. It was found that the angular momentum of a protoplanetary disk is misappropriated when compared to models during stellar bursts. Sun and other stars are predicted by models to be rotating considerably faster than they actually are. Professors Colgate and Petchak from Los Alamos Science, in article Angular Momentum, the Cosmic Pollutant, wrote, there seems to be too much angular momentum in the universe to allow the formation of stars or the accretion of matter onto variable X-ray sources. This fundamental problem begs for solution. When we have too much of something and cannot find a way of getting rid of it, we often think of it as a pollutant. In the game of concentration and collapse of matter in the universe, from clouds of gas to clusters of galaxies, stars, planets, and black holes, angular momentum is the pollutant that prevents the game from being played to the absolute limit, namely collapse onto one awesome black hole for each cluster-sized cloud condensed from the early universe. It is so simple to name something, I mean angular momentum problem, as the pollutant, and then forget about it. And this is the cosmological science. It's unbelievable. In my opinion, angular momentum problem is the killer of all existing cosmological models, including Big Bang model. All timers of cosmology should solve this problem. To the best of our knowledge, the modified in 2018 Hypersphere World-Universe Model is the only one cosmological model in existence that is consistent with the law of conservation of angular momentum. I absolutely agree with Richard Feynman, who said, "It doesn't make any difference how beautiful your gas is. It doesn't make any difference how smart you are, who made the gas, or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it." Short history of solar system formation. The most widely accepted model of solar system formation, known as nebula hypothesis, was first proposed in 1734 by Swedenborg and later elaborated and expanded upon by Kant in 1755. Can you believe it? About 300 years it was proposed, this model, and still there is nothing principally new. It maintains that 4.6 billion years ago, solar system formed from the gravitational collapse of a giant molecular cloud, which was light years across, with a certain amount of angular momentum. Where it came from? Most of the mass collected in the center, forming the sun. The rest of the mass flattened into a protoplanetary disk, out of which the planets and other bodies in solar system formed. The nebula hypothesis is not without its critics. In his The Wonders of Nature, Farrell outlined the following counter-arguments. It contradicts the obvious physical principle that gas in outer space never coagulates, it always spreads outward. Each planet and moon in solar system has unique structures and properties. How could each one be different if all of them came from the same nebula? A full 98% of all the angular momentum in the solar system is concentrated in the planets, yet a staggering 90.8% of all the mass in our solar system in the sun. Jupiter itself has 60% of the planetary angular motion. Evolutionary theory cannot account for this. This strange distribution was the primary cause of the downfall of nebula hypothesis. There is no possible means by which the angular momentum from the sun could be transferred to the planets. Yet this is what would have to be done if any of the evolutionary theories of solar system origin are to be accepted. Speaking of the mass angular momentum problem, Bergamini says, a theory of evolution that fails to account for this peculiar fact is ruled out before it starts. Lunar origin fission hypothesis was proposed by Darwin in 1879 to explain the origin of the moon by rapidly spinning Earth, on which equatorial gravitative attraction was nearly overcome by centrifugal force. Wise made a detailed analysis of this hypothesis in 1966 and concluded that it might seem prudent to include some modified form of rotational fission among our working hypotheses. Solar fission theory was proposed by Jacquard in 1951, who stated that the planets were expelled from the sun one by one from the equatorial bulge caused by rotation. One of these planets shattered to form the asteroid belt. The moons and rings of planets were formed from the similar expulsion of material from their parent planets. Von Flander extended this theory in 1993. Flander proposed that planets were expelled from the sun in pairs at different times. 6 original planets exploded to form the rest of the modern planets. It solves several problems that standard model does not. If planets fission from the sun due to overspin while the protosun is still accreting, this more easily explains how 98% of the solar system's angular momentum ended up in the planets. It solves the mystery of the dominance of prograde rotation for these original planets, since they would have shared in the sun's prograde rotation at the outset. It also explains coplanar and circular orbits. It is the only model that explains the twinning of planets and moons and difference of planet pairs, because after each planet pair is formed in this way, it will be some time before the sun and extended cloud reach another overspin condition. The outstanding issues of the solar fission are: it is usually objected that tidal friction between a protoplanet and a gaseous parent, such as the protosun, ought to be negligible because the gaseous parent can reshape itself so that any tidal bulge has no lag or lead and therefore transfers no angular momentum to the protoplanet. There would exist no energy to allow for planetary explosions. Neither Jacquard nor Von Flander proposed an origin of the sun itself. It seems that they follow the standard nebular hypothesis of formation of the sun. In Hypersphere World-Universe Model, we concentrate on furthering a solar fission theory. What else we can use? That's it, what we have in literature right now. Explosive volcanic rotational fission model. This is the name of our model. To be consistent with the law of conservation of angular momentum, any theory of evolution must answer the following questions. How do galaxies and extrasolar systems get their substantial orbital and rotational angular momentum? How did Milky Way galaxy give birth to different extrasolar systems in different times? The age of Milky Way is about the age of the world. What is the origin of Milky Way's huge orbital and rotational angular momentum? We must discuss the beginning of Milky Way. The oldest star in Milky Way, Methuselah, is nearly as old as the universe itself. How did it happen? The beginning of solar system was 4.57 billion years ago. What is the origin of solar system rotation and orbital angular momentum? We must discuss the beginning of solar system also. Wang et al. In 2021 made a great discovery. Most cosmological structures in the universe spin. All the structures in the universe form on a wide variety of scales, from small dwarf galaxies to large superclusters. The generation of angular momentum across these scales is poorly understood. We must discuss the beginning of the world. Rotational fission. In our opinion, there is only one mechanism that can provide angular momentum to macro objects: rotational fission of always spinning, surface speed at equator exceeding escape velocity, prime objects. From the point of view of fission model, the prime object is transferring some of its rotational angular momentum to orbital and rotational momenta of satellites. It follows that rotational momenta of prime objects should exceed orbital momenta of their satellites. In frames of Womb, prime objects are dark matter cores of superclusters, which must accumulate tremendous angular momentum before the birth of the luminous evolved. It follows that a long enough time period must elapse. We named this period dark epoch. In 2018, we modified Womb the following way and gives a principally new picture of the world. Womb introduces dark epoch spanning from the beginning of the world 14.22 billion years ago for 0.45 billion years, when only dark matter macro objects existed in the medium of the world, which we discussed in presentation 1, and luminous epoch ever since for 13.77 billion years for Laniakea supercluster, when luminous macro objects emerged due to the rotational fission of superclusters dark matter cores and self-annihilation of dark matter particles. Main players of the world are superclusters dark matter cores, which accumulated tremendous rotational angular momentum during dark epoch by absorbing dark matter particles from the medium inside of rotating dark matter cores. Their self-annihilation at each point of course generates gamma quants and clouds of different particles, atoms, ions of ordinary matter as the result of interaction of very high energy gamma quants with the surrounding particles of ordinary matter. These particles have large linear momenta in all 360 degrees. Particles with momentum directions along of course axis of rotation leave them into medium. This is a supercluster's wind, analogous to stellar and galaxy winds. Particles with momentum directions perpendicular to core's axis of rotation have different momenta depending on their directions. Particles with momenta p plus, along with local rotating speed v local, have a sun speed larger than particles with momenta p minus against v local. It means that the core has additional angular momentum according to the equation, where parameters are vectors and r local is a radius vector of the discussed local point from axis of rotation. The accumulated by dark matter cores of superclusters rotational momenta transferred to dark matter cores of galaxies as the result of their rotational fission. The experimental observations of galaxies in the world show that most of them are these galaxies. These results speak in favor of the developed rotational fission mechanism. Milky Way's dark matter core was born 13.77 billion years ago as the result of rotational fission of Virgo superclusters dark matter core. Dark matter cores of extrasolar systems, planets, and moons were born as the result of the repeating rotational fissions of Milky Way's dark matter core in different times, 4.57 billion years ago for solar system. Macrostructures of the world form from the top superclusters down to galaxies and extrasolar system. Multi-component dark matter. Wurm proposes multi-component dark matter system consisting of two couples of co-annihilating dark matter particles, a heavy dark matter fermion DMF1 and a high-spin zero boson Dirac that is a dipole of Dirac's monopoles with charge mu equals E over 2 alpha. E is an elementary charge and alpha is a dimensionless Rydberg constant. A heavy fermion DMF2 and a high-spin zero boson LO that is a dipole of preons with electrical charge 1/3 of E, self-annihilating fermions DMF3, DMF4, and boson Xion. The reason for this multi-component dark matter system was to explain the diversity of dark matter cores of macro objects of the world, superclusters, galaxies, and extrasolar systems. We discussed this multi-component dark matter system in presentation 2. Macro-object jet model. In Wurm, macrostructures of the world, superclusters, galaxies, and extrasolar systems have nuclei made up of dark matter fermions, which are surrounded by shells composed of dark matter and baryonic matter. The shells envelope one another like a Russian doll. The lighter a particle, the greater the radius of the mass of its shell. Innermost shells are the smallest and are made up of heaviest particles. Outer shells are larger and consist of lighter particles. A proposed weak interaction of dark matter particles provides integrity of all shells. Table 1 describes parameters of macro object cores, which are 3D fluid balls with a very high viscosity and function as solid-state objects. The calculated parameters of the shell show that nuclei made up of DMF1 and DMF2 compose cores of stars in extrasolar systems. Shells of DMF3 and or electron-positron plasma around nuclei made up of DMF1 and DMF2 make up cores of galaxies. Nuclei made of DMF1 and DMF2 surrounded by shells of DMF3 and DMF4 compose cores of superclusters. Dark matter cores of macro objects. In Wurm, cores of all macro objects possess the following properties. The nuclei are made up of dark matter fermions and contain other particles, including dark matter and baryonic matter, in shells surrounding the nuclei. Dark matter particles are continuously absorbed by cores of all macro objects. Ordinary matter, about 7.2% of the total matter, is a byproduct of dark matter particles' self-annihilation. It is re-emitted by cores of macro objects continuously. According to Wurm, a rotational angular momentum of overspinning, surface speed at equator exceeding escape velocity, object before rotation fission is, where g is the gravitational parameter, m is the mass of overspinning macro objects, r is its radius. These parameters are time varying. G is inversely proportional to tau, m is proportional to tau in power 1.5, and r is proportional to root square of tau. It follows that the rotational angular momentum of cores is proportional to tau squared. Nuclei and shells are growing in time. Size proportionally to root square of tau, mass to power 1.5 of tau, and rotational angular momentum proportional to tau squared until they reach the critical point of their stability at which they detonate. Satellite cores and their orbital and rotational angular momenta released during detonation are produced by overspinning dark matter cores. The detonation process does not destroy them. It is rather gravitational hyperflares. Size, mass, composition, orbital and rotational angular momentum of satellite dark matter cores depend on local density fluctuations at the edge of overspinning dark matter cores. Consequently, a diversity of satellite dark matter cores has a clear explanation. Satellite dark matter cores are given off by volcanoes on prime dark matter cores erupting repeatedly. WOM refers to overspinning dark matter core detonation process as gravitational burst, analogous to gamma ray burst. In frames of WOM, repeating gravitational burst can be explained the following way. As the result of gravitational burst, the overspinning dark matter cores lose a small fraction of their mass and a large part of their rotational angular momentum. After gravitational burst, dark matter cores of prime objects, superclusters and galaxies absorb new dark matter particles. Their masses increases proportionally to tau in power 1.5, and their angular momentum increase much faster, proportional to tau squared, until they detonate again at the next critical point of their stability. That is why dark matter cores of satellites, galaxies, stars, planets, and moons are rotating around their own axis, and dark matter cores of prime objects. Afterglow of gravitational burst is a result of processes developing in the nucleus and shells after detonation. In case of extrasolar system, a star wind is the afterglow of star detonation. Stars' dark matter cores absorb new dark matter particles, increase their mass proportionally to tau in power 1.5, and get rid of extra rotational angular momentum by star with wind particles. Solar wind is the afterglow of the solar core detonation 4.57 billion years ago. It is the result of ongoing and current dynamics within the sun. In case of galaxies, a galactic wind is the afterglow of the repeating galactic dark matter core detonations. In Milky Way, it continuously creates two dark matter Fermi bubbles. Formation of macrostructures, dark epoch. Dark epoch started at the beginning of the world 14.22 billion years ago and lasted for 0.45 billion for the Laniakea supercluster. WOM is a classical model. Therefore, classical notions can be introduced only when the very first ensemble of particles was created at the cosmological time about 10 to the minus 18 seconds. At time much longer, density fluctuations could happen in the medium of the world filled with dark matter particles. The heaviest particles, DMF1, could collect into a cloud with distances between particles smaller than the range of a proposed weak interaction. As a result of the weak interaction, which is about 30 orders of magnitude greater than gravitational interaction, clumps of DMF1 will arise. They have random initial rotational angular momentum according to the equation, where Ri is the position vector of particle I with respect to the center of mass, and Pi is the linear momentum of particle I with respect to the center of mass. Larger clumps will attract smaller clumps and dark matter particles and initiate a process of expanding the dark matter clump, followed by growth of surrounding shells made up of other dark matter particles, up to the maximum mass of the shell made up of DMF4 at the end of dark epoch. The process described above is the formation of the dark matter core of superclusters. Dark matter particles supply not only additional mass proportional to tau in the power 1.5 to cos, but also additional angular momentum proportional to tau squared, fueling the overspinning dark matter cores. We estimate the number of main supercluster cores at the end of dark epoch to be around 1,000. It is unlikely that all of them gave birth to luminous superclusters at the same cosmological time, being far away from each other. Luminous epoch. Detailed analysis of the rotational angular momenta of overspinning dark matter cores of macro objects before rotational fission showed that, as the result of rotational fission of Virgo superclusters core 13.77 billion years ago, approximately 1 million galaxies like Milky Way could be generated at the same time. Considering that Virgo supercluster has grown inside out, in the present epoch, most old galaxies can be found in the middle, more recently formed ones on the outskirts. The number of generated galaxies could be much larger. As the result of rotational fission of Milky Way core 13.77 billion years ago, about 10,000 extrasolar systems like solar system could be created at the same time. Considering that Milky Way has grown inside out, old stars are in the middle, recently formed ones on the outskirts, our Milky Way is recently formed ones, the number of generated extrasolar systems could be much larger. Extrasolar system dark matter cores can give birth to planetary dark matter cores, which in turn can generate dark matter cores of moons by the same rotational fission mechanism. Luminous epoch is the result of explosive volcanic rotational fission of dark matter cores of superclusters and self-annihilation of dark matter particles. In our view, random explosive volcanic rotational fission of dark matter cores of prime objects looks like a firework of dark matter cores of satellites objects at the same time, so that the direction of the sum of satellites' angular momentum coincide with the angular momentum of the prime object. There are no preferences of directions of satellites' rotation at any level, supercluster, galaxy, solar system, versus random rotation direction. Dark matter cores of prime objects detonate at critical points of their stability, which principally depend on the accumulated rotational angular momentum. As a summary, the rotational fission of macro objects' dark matter cores is the most probable process that can generate satellite dark matter cores with large rotational and orbital momenta in a very short time. Macrostructures of the world form from the top, superclusters, down to galaxies, extrasolar systems, planets, and moons. Macrostructures. Laniakea supercluster is a galaxy supercluster that is home to Milky Way and approximately 100,000 other nearby galaxies. It is known as one of the largest superclusters, which with estimated by Bliss binding mass about 10 to the power 17 mass of the Sun. The neighboring superclusters to Laniakea supercluster are the Shapley supercluster, Hercules supercluster, Coma supercluster, and Perseus Pisces supercluster. Distance from the Earth to the center of Laniakea superclusters is about 250 million light years. Please take a look at this figure too. This is a real picture of the world with many superclusters and overlapping each other. The mass-to-light ratio of Virgo supercluster is about 300 times larger than that of the solar ratio. Similar ratios are obtained for other superclusters. In 1933, Zwicky investigated the velocity dispersion of Coma cluster and found a surprisingly high mass-to-light ratio, about 500. He concluded, if this would be confirmed, we would get the surprising result that dark matter is present in much greater amount than luminous matter. These ratios are one of the main arguments in favor of the presence of large amounts of dark matter in the world and validate the developed model of superclusters macrostructure. We emphasize that about 100,000 nearby galaxies are moving around center of Laniakea supercluster. All these galaxies did not start their movement from the initial singularity. The neighboring superclusters have the same structure. It means that the world is in fact patchwork quilt of different luminous superclusters. According to Turing et al., galaxies congregate in clusters and along filaments and are missing from large regions referred to as voids. These structures are seen in maps derived from spectroscopic surveys that reveal networks of structure that are interconnected with no clear boundaries. Extended regions with a high concentration of galaxies are called superclusters, although this term is not precise. Wang et al. In 2021 made a great discovery. Most cosmological structures in the universe spin. All the structures in the universe form on a wide variety of scales, from small dwarf galaxies to large superclusters. The generation of angular momentum across these scales is poorly understood. We have investigated the possibility that filaments of galaxies, cylindrical tendrils of matter, hundreds of millions of light years across, are themselves spinning. By stacking thousands of filaments together and examining the velocity of galaxies perpendicular to the filament's axis via their red and blue shift, we have found that these objects too display motion consistent with rotation, making them the largest objects known to have angular momentum. These results signify that angular momentum can be generated on unprecedented scales. In 2021, Lopez reported about the discovery of a giant, almost symmetrical arc of galaxies, the giant arc, spanning 3.3 billion light years at a distance of more than 9.2 billion light years away. That is difficult to explain in current models of the universe. The giant arc, which is twice the size of the Sloan Great Wall of galaxies and clusters, that it's seen in the nearby universe. This new discovery of the giant arc adds to an accumulating set of cautious challenges of the cosmological principle. Carr et al. In 2020 considered the observational constraints on stupendously large black holes, slabs, in the mass range more than 10 to the power 11 mass of the Sun. These have attracted little attention hitherto, and we are aware of no published constraints on a slab or population in the range 10 to the power 12 up to 10 to the power 18 mass of the Sun. However, this is already there is already evidence for black holes of up to nearby 10 to the power 11 mass of the Sun in galactic nuclei, so it is conceivable that slabs exist and they may even have been seeded by primordial black holes. Boom! These latest observations of the world can be explained in frames of room only. Galaxies do not congregate in clusters and along filaments. On the contrary, cosmic web, that is networks of structure that are interconnected with no clear boundaries, is the result of the rotational fission of dark matter cores of neighbor superclusters. Generation of angular momentum across these scales provide dark matter cores of superclusters through the rotational fission mechanism. Spinning cylindrical tendrils of matter hundreds of millions of light years across are the result of spiral jets of galaxies generated by dark matter cores of superclusters with internal rotation. The giant arc is the result of the intersection of the galaxy's jets generated by the neighbor dark matter cores of superclusters. The calculated maximum mass of supercluster dark matter core, about 10 to the power 19 mass of the Sun, is in a good agreement with the values discussed by Bliss and by Carr. In the future, these stupendously large compact objects can give rise to new luminous superclusters as the result of their dark matter cores rotational fission. 13.77 billion years ago, when the Laniakea supercluster emerged, the estimated number of main dark matter supercluster cores in the world was around 1,000. It is unlikely that all of them gave birth to luminous superclusters at the same cosmological time, being far away from each other. The 3D, finite, boundless world presents a patchwork quilt of different luminous superclusters which emerged in various places of the world at different cosmological times. The distribution of macro objects in the world is spatially inhomogeneous and anisotropic, and temporally non-simultaneous. Cosmological principle is valid for the homogeneous and isotropic medium of the world, consisting of elementary particles with 2/3 of the total matter. The distribution of macro objects with 1/3 of the total matter is inhomogeneous and anisotropic, and therefore the cosmological principle is not viable. The main conjecture of Big Bang model, projecting galaxy trajectories backwards in time, means that they converge to the initial singularity at T0 equals 0, that is an infinite energy density state, is wrong, because all galaxies are gravitationally bound with their superclusters. Big Bang never happened. GWST discoveries. The problem of ancient galaxies formation is a long-standing problem. The age of the universe is 13.77 based on the cosmic microwave background data. Astronomers believe that our own Milky Way galaxy is approximately 13.6 billion years old. Milky Way is one of the two largest spiral galaxies in the local group, the other being an Andromeda galaxy. Massive, mature disk galaxies like Milky Way cannot form so soon. Distances to remote objects other than those in nearby galaxies are nearly always inferred by measuring the cosmological redshift of their light. An important distinction is whether the distance is determined by spectroscopy or using a photometric redshift technique. The spectroscopic redshift is conventionally regarded as being necessary for an object distance to be considered definitely known, whereas photometrically determined redshifts identify candidate distant sources. For comparison with the light travel distance of the astronomical objects listed below, the age of the universe since the Big Bang is currently estimated at 13.787 billion years. Below, we discuss macro objects with Z over 10. In Table 2 are presented the results for most distant galaxies with spectroscopic redshift determination. The most interesting is HD1, we will discuss later. In Table 3 are presented notable candidates for most distant galaxies. F200DB045 is the most interest in this group. The presented experimental results show that HD1 is one of the earliest and most distant known galaxies yet identified in the observable universe. HD1's unusually high brightness has been an open question for its discoverers. It has a significantly more luminous ultraviolet emission than similar galaxies at its redshift range. F200DB-045 is a candidate high redshift galaxy with an estimated redshift 20.4. If confirmed, it will be one of the earliest and most distant known galaxies observed. This galaxy would have a light travel distance, look back time, more than 13.7 billion years. Detailed analysis of observations of the first batch of candidate objects revealed by GWST is done by Yan in 2022. The summary of GW discoveries in the early world is: the most secure oldest galaxy is Glass Z13 that has already built up to 1 billion mass of the Sun in stars. The search of 88 candidate galaxies at Z over 11 shows that some of them could be at redshifts as high as 20. Some of those distant galaxies are strikingly massive, 10 times more massive than Milky Way. A new redshift record obtained for galaxy candidate Cirrus 93316 at Z16.7 with a stellar mass about 1 billion mass of the Sun. 7 galaxies with M mass more than 10 to the power 10 mass of the Sun and Z in the range between 7 and 11 were found in the survey area, including 2 galaxies with mass about 10 to the power 11 mass of the Sun. The stellar mass density in massive galaxies is much higher than anticipated from previous studies. A factor of more than 3 orders of magnitude at Z about 10. Extremely compact bright galaxies were found at Z in the range between 12 and 17. Super early, massive, evolved galaxies with blue spectra and very small dust attenuation. So much news. Warm explanation. These latest observations by GWST of the world can be explained in frames of room only. It is a question of time. The beginning of the world was 14.22 billion years ago. Dark epoch, when only dark matter macro objects existed, lasted for 0.45 billion years. Luminous epoch exists ever since for 13.77 billion years. Early galaxies formed in near-present configuration as the result of transition from dark epoch to luminous epoch. due to the explosive volcanic rotational fission of overspinning dark matter superclusters cores and self-annihilation of dark matter particles. Ordinary matter is a byproduct of dark matter particles self-annihilation. There are no proto-galaxies in the world. That is why GWST did not see their images. Compact disk galaxies emerged as the result of the rotational fission of the overspinning dark matter cores of superclusters. Each of them have one dark matter core. There are no frequent mergers of galaxies at the early epoch. According to standard cosmology, massive mature disk galaxies with mass up to 10 to the power 11 mass of the Sun cannot form so soon because it takes billions of years to form them, and so should not be there at all at the beginning. We hope that oldest galaxies with high redshifts over 24, light travel distance more than 13.7 billion years, will be confirmed. It depends on the physical parameters of GWST. Disk galaxies. The experimental observations of galaxies in the world show that most of them are disk galaxies, which can be explained the following way. Galaxies emerged due to the explosive volcanic rotational fission of overspinning dark matter supercluster cores. As the result of this mechanism, galaxy bubbles created which have looked like chicken egg at that time. Yolk, spinning liquid dark matter core of galaxies with high viscosity, composed of dark matter particles DMF1, DMF2, and DMF3. Yolk contains 1/3 of the total galaxy matter. Albumin, liquid interstellar medium with low viscosity made of DMF3 with dissolved other dark matter particles. Albumin adds up to 2/3 of the total galaxy matter. Membrane, boundary between interstellar medium and intergalactic medium with surface energy density sigma 0, where H is a Planck constant, C is a gravitodynamic constant, and A is a basic size unit. Extrasolar system emerged due to the explosive volcanic rotational fission of overspinning dark matter galaxy core and enter interstellar medium. As a result, galaxy bubble expands in the plane of the spanning galaxy's dark matter core and becomes a disk bubble. Conclusion. In the first presentation, I named three main pillars of WOMB: medium of the world, dark matter, and angular momentum, which is one of the most critical problems in standard cosmology that must be solved. Hypersphere World-Universe Model is the only one cosmological model in existence that is consistent with the law of conservation of angular momentum. The described picture of the world is in fact a paradigm shift for cosmology. Astronomers have great achievements in investigations of macrostructures of the world. We are at the beginning of a new era of astronomy, cosmology, and astrophysics. Young physicists should be a part of it. They should concentrate their efforts on the development of a new cosmology and classical physics. I'm very excited about the future of physics. Acknowledgements. I'm always grateful to academician Prokhorov and Professor Manenkov, whose influence on my scientific life has been decisive. I am eternally grateful to my scientific father, Paul Dirac, who was a genius and foresaw the future of physics in a new cosmology. I am forever grateful to Nikola Tesla, who was a genius. I am much obliged to Professor Korda for publishing my manuscripts in the Journal of High Energy Physics, Gravitation, and Cosmology. I am grateful to Nick Percival for his useful comments and suggestions which have led to an overall improvement of the presentation. Special thanks to my son Ilya, who helped me clarify the model and improve its understanding. Thank you so much for your attention. This is the end of the presentation. Let me clarify the point of Big Bang model. First of all, from one side, 13.77 years ago, it was like an explosion, firework of superclusters, dark matter, supercluster 4. It's from one side, and you can name it as a Big Bang. But from the another side, Big Bang supposed that it was some initial singularity. And in my conclusion, I was against initial singularity because all the existing galaxies, they bounded with their supercluster. There is a patchwork quilt, that's it. That's why you can name this transition from dark epoch to luminous epoch like a Big Bang, but I don't like this word even, this combination of words, because there was no Big Bang. It was a transition from one condition of the world to another condition, from dark matter epoch, 4.45 billion years, to luminous epoch we live in. That's it. Big Bang model, this is the most acceptable right now model, but it is obsolete. It never discussed rotational angular momentum, orbital angular momentum, any angular momentum. You know, it is pollution. You're absolutely right. And nobody wants even to talk about it. It doesn't exist as that's it. This is the science to forget about one of the most important parameters. In even the spiral galaxies, you know, with a huge angular momentum, nobody even touching it. There is an experiment and there is no any explanation for it. Our dark model, they created by universe continuously. We have all the time matter coming to our world. Who is the creator? The universe. That's it. First of all, I would like one more time to state how much I am thankful to Nick for his recommendations about my presentation. I will tell you why. Because when he read my presentations, I have text of my presentation, I presented it to you today. He told me, Vladimir, you have so much that if you will not read your text, nobody will understand anything because everything principle in you. I know how it's difficult to take new approach, new model, new ideas at once. And I try to concentrate all the ideas around angular momentum in one speech for 1 hour only. Of course, I didn't present all the results, all the information about it, because it is impossible to do it. I'm developing this model for 23 years. That's why I collected so much information. I developed so many different models, different ideas of my model. That's why, you know, it's very difficult to put all these results in each presentation. 8 of them, even 8 of them, will show only some results of my investigation. But what is the most important? I will tell you. I am trying always to follow experimental results.